So some vocabulary or some terminologies that we use in Kubernetes, we'll have a look at that. We already saw pods, right? So pod is nothing but the smallest unit that you deploy when you deploy an application. Smallest unit, that means smallest process, I would say. It is different from containers in the sense it's a wrapper over containers. So let's say usually a pod would have single container running inside it, but sometimes it may have more than one container. Usually it would be like one main container having the main logic, and the other one would be some helper process like logging or some health check or something, some cache component or something like that. So the other one would be a minor process that is a helper function that would be there for the main container. Usually pods would contain one container. So pod is the smallest deployable thing. So whenever you deploy an application pods would get deployed. Then there is something called as deployment. So deployment is a Kubernetes abstraction that manages the pod. So let's say you are having that web UI for your shopping website, right? So the web UI, you just can't have one pod running for the UI. You might have numerous pods running the web UI service because you want to manage the load of incoming requests, right? So if you have, let's say, 5 pods running for the web UI, all these 5 pods you don't want to manage individually. So you sort of create an object called as deployment, and you specify the pod inside the deployment, and the deployment would actually take care of updating the pods or maintaining the correct number of pods for you. So inside the deployment object, you would specify, I want 5 pods of this application running always. So deployment will always take care that 5 pods are running for you no matter what. Also, it would take care of upgrades. If you want to upgrade from version 1 to version 2, then it would take care of that also. Then there are services. So I just mentioned that pods get IP addresses, right? But pods are ephemeral in nature. That means if the pod goes down and deployment brings up another pod in that place for your application, the other pod would have a different IP address. Now then, how do you keep track of all this changing? Because pod can go down and come up anytime and numerous times, right? So you don't want to manage these IP addresses all the time. So what you do is, like deployments, you create an abstraction. That means you create a logical object which would have at the backend, it would have the information of all the pods that it has at the backend, and you assign IP address to the services. So basically, service is something you expose to the outer world, and outer world would actually contact the service, and then service would take care of actually tracing the request back to one of the pods. So that is a service concept. Then there is something called as namespaces. So a Kubernetes cluster would be used by multiple users, multiple organizations, or multiple departments within one company. So you want a way to isolate their own applications. You don't want one application to overlap or unnecessarily contact to the other application. You want some policies to be set up, which you don't want to set up across the cluster. You want to just set up it to a subsection of the cluster. You want to apply authentication. For all these purposes, you can sort of create an isolated environment within the clusters, and which is called as namespace. So applications or pods or services running within the namespace can have the same names, let's say, as applications or pods or services that are running in the other namespace. Basically, you are kind of isolating the two environments on top of same cluster. So just some graphical representation to make understanding easier. This is our worker node, and let's say this is the pod. Let's say this is a UI or UI that you are running inside the pod. So pod may consist of one or more containers. That is what we have just seen. Now let's say you also have a database service running. and you have another pod that is managing your database. And so your UI, whenever some request comes in, some data gets generated and it contacts the database by using its IP address, and that's how they to communicate with each other, right? But now, so what happens if UI goes down? Like that means the pod running the UI goes down. The deployment would take care of it, and you would have a new pod coming in. But now this new pod would have a different IP address. Now, how does the database service knows what IP addresses to contact to, right? So what happens is that is where the services come in picture. So you create a service object, and this yellow object is like a wrapper or like a front end where you expose the pod or the services that are running from the pod, and the DB would actually have service, the DB would actually know the service and not the pod that run behind it. So DB would usually talk to this yellow part, that is a service, and below that the pods can go down and come up and have different service, different IP addresses. It doesn't matter to the external world. Kubernetes takes care of pod coming up and going down and managing the service accordingly, but services is what you would contact rather than directly contacting the pod. So services provide consistent interface to pods at the backend, right? Even if the pods go down, the consistent interface would still be there. So now let's say your application, you specify that I want to run 4 pods for my UI, right? And what if one of the pod goes down? So this is where the deployment comes in picture. So when you specify deployment, you actually specify the number of replicas that you want to run always. So if I specify replicas as 4, the deployment, it would notice that one of the pod has gone down, and it would immediately deploy another pod in that place. So it would ensure that at any point of time, you will always have desired number of pods running on the cluster, right? Now, let's say you want, you updated the code, and now you want to release the version 2 of your application. So that also is taken care by deployment. So what it would do is it would actually bring down the version 1 of the pod, and it would spawn the version 2 of the pod, and you can tell it whether you want to do it one by one, like all the other pods would be still running version 1, but the first pod would get updated to version 2 and it would be done one by one, or you want to bring down the all pods simultaneously and simultaneously have version 2 in all the pods, that you can tell the deployment. Now there are some more objects. Usually any applications, right, they would need some sort of config, they would have some sort of config files, or they would need some config data, like what ports they are exposing, or anything like some config file where the path of config files that application needs, or some environment variables that it needs access to, and all sort of things. So if you make that as part of your application image, and let's say tomorrow I want to change the file path, I'll have to build the application again. I'll have to again create a Docker image and then deploy the pod or deployment again on the Kubernetes. And these config parameters may keep changing, and you don't want to do that always. So what you do is you actually create a different object which are like a key value pair. So whatever data you want to store, that you want to pass as a config to the application, you stored it in a config map. So config map is an object that stores the config and for the app in an external object, and then you just inject that config map onto your pod. So even if your pod goes down or whatever, the config map can still be there. And if you want to change the config parameter value sometime, you can change the config map. The same config map will be used by the pod. Now, secrets is somewhat similar. It's just that if you want to store some sensitive data like password or token or certificates, then you would use secret, so that in config map, the data is stored as it is. That means it is readable by anybody. But when you create a secret, the data is encoded and stored so that it is not usually readable as such when you open a secret. But both the things you can actually inject inside the pod, in the sense you can specify saying, okay, I want to use this config map, and then the application running in the pod would have access to those parameters or those variables, or those passwords if you are using secret. Then volumes, right? So because the containers are ephemeral, whatever data that gets generated as part of your application process, or whatever changes you want to do, if you do it inside the container, as soon as the container finishes its work, the container dies, and all the data that is there would die with that. If you want to persist the data even after the container process has finished working, then you want to have some persistent storage. So basically you want to have some storage outside the container, volumes, right? And Kubernetes supports all these volumes like AWS EBS, which is block storage from AWS, or Cinder, which is block storage from OpenStack. So a Kubernetes admin would actually create these volume blocks for you on the underlying cloud, let's say, and these actual volumes or disk would be available to you as application developer for using those volumes. And you can create persistent volume claims, wherein you would tell, I want this much size of a storage and some other parameters, and then Kubernetes will map your claim to one of the available volumes, and you can use those volumes like a mounted disk inside your application, and you can store or persist your data even after your application finishes running. Again, this was not an exhaustive list of objects that we talked. There are still some more concepts like ingress or stateful sets that are very integral to Kubernetes. But I mean, we would run, it would be out of scope for a Kubernetes overview. So I just described the very common objects that are there. Now, where do we run a Kubernetes cluster? So there are different ways. Let's say you are a student or you are learning Kubernetes and you just want to play around, learn the concepts, just try a few things. Then you need not go to the extent of creating a whole cluster, acquiring virtual machines, and creating a master node architecture and all that. You can use something called as Minikube. Minikube is a utility to run the Kubernetes on local computer, and you can use it on your local Windows or Mac, and it's like a single node cluster. Your computer itself will act as master as well as worker, and you can deploy a few Hello World applications and just test and learn about Kubernetes. So it's a very good way to start learning Kubernetes. Then there is a Kubernetes multi-node cluster, which is like a production environment wherein you will have some number of masters and some number of workers running and actually running on either on-prem data center or some cloud. There is something called as Google Kubernetes Engine. So it is hosted and managed by Google. It runs on top of Google Cloud. So basically it runs on the VMs that are spawned on the Google Cloud. Now, I have a demo wherein I have just deployed a very basic Hello World sort of an application. I used Minikube here. So I'll fast forward the demo if I think it's not necessary. So basically I just looked at what Minikube version is, what Docker version is, right? So you can just give those commands. Then if you can give the Minikube status command, it will show you the status of host, kubelet, API server, all the services running, right? Then there is a command called kubectl cluster info. It will show you master is running at this IP and port, and kube DNS is running. So there is a DNS server that comes with kubectl. Kubectl is a CLI client that you use to talk to your Kubernetes cluster. Basically, it's Kubernetes CLI. And these are the basic commands, right? So kubectl get nodes. Because I'm running Minikube, it's a single node cluster. I can see that my node name is minikube and its role is master, but it itself is also acting as worker. If I had more than one node, I would have seen it here in the list. Kubernetes objects usually have some short names also. So instead of saying namespace, I could just say kubectl get ns, and these are the namespaces that are there in the cluster right now. The default is the default namespace. Usually when you log into Kubernetes, you would be inside a default namespace, right? If I do a get pods, I would say that no resources or no pods are running in the default namespace right now. If you want to see the pods running in the kube system namespace, kube system is the system wherein Kubernetes' own services run, the services which we just saw, like kube API server or scheduler or the etcd, right? All these run in the namespace called kube system, right? So you can see all these pods are running, right? Now, if you see a kube, get deploy is get deployment. There is no deployment that is running in the default namespace right now. Now I'll just show a file wherein, so the Kubernetes had something called as manifest for objects, right? So how do you create all these objects, pods and deployments, right? So you can create YAML files. This is called as manifest. It has 4 components like API version, kind, metadata, and spec. In any object, all these 4 components are present, right? And you can specify the kind is a deployment. So that means if I wanted to deploy a pod, not a deployment, I would have specified kind as pod, or a kind can be a service. So object type is a kind. Metadata is any metadata related to that object, right? So I just gave name to my deployment. Then there is spec. That spec is specification. So inside the spec for deployment, I am giving the pod details. That means I am giving that the pods that run as part of this deployment would have labels as application as Nginx, and the specification of the pod mentions how many containers I'm running, right? So right now I'm running one container as part of pod. Its name is Nginx. The image I'm using to run the container is this one, and the container port will be 80, right? So basically when I do this deployment, a pod would get deployed, and the deployment will also get created. Now you can either do a kubectl create -f and use this file to create a deployment from the file, or like I just did, kubectl create and deployment Nginx, and I can specify the image here. So this is like very basic. So now a deployment Nginx has been created. If I do a kubectl get deploy, yeah, I would see it's still not ready. So you might have to wait a few seconds. Now it is ready, right? So out of 1, 0 was ready. Now out of 1, 1 is ready. Basically, it's up to date. Now to see the details of any objects, you just do a kubectl describe and object type and object name. So what I did was, so what I did was I just described the deployment, and yes. So if I just did a kubectl describe deploy Nginx is my deployment name. You can see it's in the namespace default. It has labels app equal to Nginx, right? It has replicas 1. So only 1 pod will get created. If I had mentioned 2, it would create 2 pods, right? And then it has information like image and other things, right? So see, if you see image is Nginx, right? And some other events and other information also it would contain. So to look at details of any objects, you do a kubectl describe. Now, if I do a kubectl get pod, you can see one Nginx pod is deployed as part of the deployment, right? Now, what I will do is, because I deployed Nginx, which is an web server, right? I wanted to create a service which is create SVC, and I want so that I would be able to access that web server. Something like a hello world should be displayed, right? So what I did is I did a create SVC command. The node port is a service type. Now this discussion is out of scope for today, but there are different service types, and one of the service types of services that you can create on Kubernetes, one of them is node port. In node port, what happens is one of the port on your node, which is the minikube node, right, that I have, it will be exposed. for the outside users. So now if you see, sorry. So now if you see, yeah. So now if you see, right, I created a service called Nginx service. Then this, it would use the TCP, and it would have the container port as 80. So if I do a get SVC, you would see a name Nginx, type as node port. There is other type called as cluster IP. The service has got an IP now, you see. And then there is a port 80, container port 80, and this other port that you see is the port that is exposed on the node. That means on which the Kubernetes cluster node, right? You can just do a describe SVC and it will show you the details. Now, how do I access my web server? Now my web server is already running, right? So I can use this Nginx service and this port to access my web server, right? So what I'm doing now is, first I need to get the access to my node. So my node is accessible by name Minikube, right? Now if I do a curl name of node colon this port 30956, I should be able to access my web server. Yes. So if you see, right, welcome to Nginx, something like a hello world sort of. So I'm able to access my web server at curl minikube colon port. So this is, so now your application is deployed. So this is how you would deploy. So I didn't have the dashboard that time, so I couldn't show, but you can actually go to a browser and you just put this minikube colon 30956, then you would be able to see the whole thing in a browser, right? So this is how you would be able to deploy a basic application. So I'll just quickly go through the related process. So whenever you want to deploy Kubernetes in production, right, you would want to have a whole ecosystem, some other solution which are not part of Kubernetes to work with Kubernetes, like Istio. So when you have different thousands of applications running and thousands of microservices running, how do these microservices, if they want to contact each other, how do they discover each other, or how do they communicate with each other? Somebody has to manage these many services. So that tool is called a service mesh. Istio is one of the service mesh to securely connect the microservices to each other. It also provides capabilities like load balancing, firewall. Then you would also need some monitoring and alerting solution, right? So there's something called as Prometheus. That is a project or monitoring tool which is cloud native, and you can integrate it with the workloads of with the Kubernetes to monitor your workloads, and you can specify the metrics, and you can also integrate it with the data visualization tools like Grafana to have a graphical view of your data. Then there is something called as Kubeless. So if you have heard of function as a service, right, wherein if you just want to do some simple task, for that you don't want to take the pain of actually deploying a VM and then setting it up and then running your code. What you can do is you can just provide the sample of code to Kubeless, and it would execute it for you and just give you the output. You don't have to deploy or have containers or anything. So that is known as function as a service. So Kubeless is a project that provides this serverless functionality on top of Kubernetes. All these three projects I talked about are open source. So all of them are actually freely available for use. Now, we saw what Kubernetes is, how it is used and all. So what is the current and future scope, right? So because all the application development that is happening in the world is moving on to cloud, it's all becoming cloud native. Container and microservice architecture is what you will see going ahead. And then because of the scale and the other requirements, right, the container orchestration is a must today. So Kubernetes has become a de facto platform to deploy apps. So any applications that you may actually use on the internet might as well be running on Kubernetes, right? I mean, 80% of them. And this is a relatively new and hot field to enter into currently, because not many people, so many people are still learning about it. Many people are not that thorough with it. So it's a very promising field right now. Then there is a rapid shift towards the cloud native deployment developments, as I just mentioned. So also there is hybrid and multi-cloud environments, right? So Kubernetes work with in all these scenarios. So even if your application actually spans multiple clouds and multiple geographical locations, Kubernetes works very well with that in that scenario. Kubernetes has received support from all the major giants, you name it, and all the companies do have some Kubernetes connection, and many people are working in Kubernetes in these companies, right? How to learn if you are not working on it? There are very standard paths available for certification. These certification are provided by Linux Foundation, so they are very well recognized. And if you have this certification on your resume, you will get call for Kubernetes roles, right? So these certifications, 3 certifications are available: Kubernetes Certified Kubernetes Admin, which is CKA, Certified Kubernetes Application Developer, CKAD, and Certified Kubernetes Security, so CKS. All these are available. They are available on Linux Foundation website, and of course you can use Minikube and other sort of things to practice. Just to end, right? So what are the job opportunities? These are the type of roles that you can actually take up if you are expert in Kubernetes. So DevOps engineer, right? Combo of software development practices and IT ops. So just to shorten the software development life cycle, the DevOps concept has come up. So an engineer introduces the processes and methodologies, and he introduces the tools and uses the tools for smoother and continuous delivery of software products to the end user, right? So that is a DevOps engineer. Cloud engineer. So cloud engineer is someone who has the technological duties related to cloud computing. So managing and maintaining the AWS infra or OpenStack infra or Google Cloud infra, and managing the services on top of it, managing the quotas on, on basically managing the whole platform on which the applications would run is something cloud engineer does. And you need to have very good knowledge of Kubernetes for that. And then there is software architect role, right? So when it comes to architecting, that means designing the whole products. You need to know what sort of platform you want to use. You need to know the nitty-gritties of the decisions that you take. So it's a very important thing to know about the Kubernetes platform if you want to become an architect down the line. So I would say Kubernetes is very hot right now. It's very much in demand. And if you do certifications, if you actually learn about it and practice it, then sky is the limit today, right? So yeah, that's it from my side. Now I'm open to questions if there are any.